In our isotopes of Beanium lab, you started with a beaker mixed full of different beans. So in my beaker that I had a total of 343 beans. That is all of them, the black beans and the red beans and the white beans combined. So of those 343 beans, I had 91 black beans, I had 72 red beans, and 180 white beans. This number plus this number plus this number will add up to that number. When I put my 91 black beans on the scale, they weighed 19.37 grams. When I put my red beans, my 72 red beans on the scale, they weighed 39.49 grams. I know you're not talking over me. Stop. When I put my 180 white beans on the scale, they weighed 34.89 grams. So you should have masses and numbers of beans for each color. Then the average mass of one bean is what you are calculating right here on number 4. You take the mass of all of your beans, so 19.37 for my black beans, divided by the number of black beans that I had, which was 91. And when I plugged that into my calculator, I got 0.21 grams. Your average right here, regardless of what your mass and your number were, your average should be really close to mine, because this is the average mass of a black bean. If yours is off by more than like 0.1, you probably did something wrong. So your number of grams will go here, 0.21, and then you're going to do that same thing for each of the others. In this next section, this is where you're calculating your percent abundance, so this is number 5. You're going to take your number of black beans, so I had 91 black beans, and I'm going to divide that by 343 black beans, because that was my total number of beans. I'm going to use that 343 on the denominator for all of them, and then multiply by 100 to turn it into a percent. So when I did that for my black beans, the percentage that I got was 26.53%. When you're checking yourself, all of your percentages should add up to 100%. And then at the bottom, you're going to use this number and this number to calculate your actual average atomic mass. So I'm going to start with my percent abundance of black beans, written as a decimal, so basically just taking away the times 100 part. So 91 divided by 343 will give me 0.2653. So that number, my percent abundance, written as a decimal, times the mass of my black bean, which would be 0.21. Then I add to that whatever this percent abundance is times that, plus this percent abundance times this. And then when I'm done, my final answer with my data that I calculated was 0.27087 AMU. So that's the front page. I'm going to talk about the back real quick. A lot of students were asking me how to do this one. I'm asking you to estimate. What I'm asking you to do is use the percent abundances to estimate which mass you're closest to. Don't forget that this is a mass, and you're going to use those masses in this question down here as well. Any questions on any of those? All right, do it.